I wanted to help you with these U-substitutions. I only have 5 minutes, so I'm just going to do this first one. I wrote what I understood from the way that you typed it, and hopefully it's correct. So that's right here. And when I'm doing U-substitution, if I see a situation where I have e to the something, so instead of e to the x, this is e to the negative x squared. I know that I want to get it into the form of e to the u because that is really easy to take the antiderivative of. So that means that I'm going to make my u substitution what the exponent of my e term is. And we'll see that that will work out really well because it's going to cancel this x out when we switch to in terms of u. So once I have done my u substitution, I've decided that u is equal to negative x squared. The next thing that I want to do is I want to take the derivative with respect to x of that. So du over dx, I get that that is equal to negative 2x. And what this does for me is it's going to allow me to solve this equation so that I can get a value for dx. Because I have this dx term here, and when I do u substitution, I want to get it in terms of u, which means I should have a du. So when I solve for dx, that's going to let me plug that into my new integral. So my new integral is going to have my substitution for dx. It has e to the u instead of e to the x, but then it's got the rest of it. One important thing to note is that since this is a definite integral, when we started, we had our bounds in terms of x, and now we need to have those in terms of u. So over here in pink, I showed how I did that. So I have u equals negative x squared. So for this bottom term here, if x is equal to 0, I can find that u is also going to be equal to 0. For my upper bound, where I had 2, I can figure out that that in terms of u will be negative 4. So when I rewrite my integral in terms of u, I'm going to rewrite those bounds. Because if you leave it in terms of u and you solve your u integral from 0 to 2, you're not going to get the correct answer. So now that I have everything in and simplified, looking at this, I see that my x's cancel out. And that's how I know that I'm on the right track. Some problems, you'll pick the wrong substitution at first, and you'll get to this step, and you'll see that you do not have an integral that's all in terms of u. I need all of these x's to be gone so that I can finish solving this. So these x's cancel each other out, leaving me everything in terms of u. And so I just continue to simplify. Negative 4 over 2 gives me negative 2. Which I pulled outside of the integral. You can do that with any constant. And that leaves me with my integral e to the u du, which, like I said in the beginning, is a really nice one because the antiderivative of e to the u is just e to the u. And where I've written it here, I have a little plus c. That's important if you're doing an indefinite integral, but since this is a definite integral, we don't need to include it. So down here, I have my final antiderivative, and I'm going to evaluate it from 0 to negative 4. So here I've just plugged that in. I have e to the negative 4 minus e to the 0. And when I simplify that out, it's something you would need to put in your calculator or leave in terms of e so that it just looks nicer. But I hope this answered your question. If you need any more help, please leave a comment. Thank you.